Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Exponential Functions. Question 2, Use of power rule of logarithms to solve an exponential equation. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. All right, so what I would do, if I could do it, is stick every single Algebra 2 student with a healthy dose of their inner mathematical genius. Therefore, inbox me at memedicine@gmail.com to help get your healthy dose. If you have friends, classmates, and or colleagues who are taking Algebra 2 with you as well, tell them to inbox me at memedicine@gmail.com. Let's delve into the topic. Question 2, exponential equation. In the equation, y equals 0.5 times 1.21 to the x, y is equivalent to the number of snowboarders in the millions, and x is equivalent to the number of years since 1998, of course measured in years. Find the year in which the number of snowboarders will be 10 million for the first time. Definitely press pause if you need to, and I'll give you a moment to think. And hint, hint, this is an exponential growth function because the question specifically says 10 million for the first time. All right, so hopefully by now you were able to arrive at a solution, specifically the value of x, because here in the question stem we're told a value for y. Okay, and if not, again, that's completely fine. We're going to do this together. So what we're going to have to do, obviously, is substitute 10, which represents 10 million, into this equation, okay? And we don't have to write out 10 million since we're told the unit measurement of y is in the millions. All we have to do is write out 10, because if we were to write out the number 10 million here, it would be 10 million times a million, and that's not what we're looking for. All right, so here goes our equation, and we're substituting 10, okay? All right, so 10 is equivalent to 0.5 times 1.21 raised to the x. The next thing that we're going to do, obviously, is divide by 0.5 in an effort to isolate the exponential term, okay? So dividing by 0.5, division by a decimal is like multiplication, okay? So when you divide by 1/2, you get 20, and the 0.5 or 1/2 cancels on the right-hand side of the equation. All right, and now to get the x down from the exponent, we have to take the logarithm of both sides, and we're going to use the common logarithm, which is the log base 10. So the log, and here the base is 10, but we don't write that in algebra because it's redundant to do so. It's just understood that if you don't see a base, the base is 10. So the log of 20 is equivalent to the log of 1.21 raised to the x, okay? Now for the fun part, we're going to use the power rule of logarithms to simplify the right-hand side of the equation, okay? And if you watch some of my basic videos in the Algebra 2 exponential and logarithmic equation series, you would have understood what's going on here. Or maybe you just understand already, which is great. And if you don't, that's great too. That's why we're going to do this example and learn together, okay? So the power rule of logarithms says that the logarithm of a power raised to an exponent is basically going to be equivalent to the exponent times the logarithm of the power, or the base, okay? So the log base 20 is equivalent to the exponent times the log of the power. And remember, if you watch my basic series on exponential equations, you would know that the result, or logarithmic equations rather, the result, or the number written out next to the log is the result, also referred to as a power. A lot of people call exponents powers, but that's a misnomer, all right? Now, what we're going to do is solve for x. So obviously, we have to divide by the log of 1.21 on both sides, okay? So the log of 20 divided by the log of 1.21, well, this is a part that you just plug into your calculator and make things really simple. And when you do that, you should get 15.72. Okay, so what we're now going to do is add 15.72, because this is the number of years since 1998. If you scroll back to the first page, and this adding this amount of years to 1998 will tell us the year in which the number of snowboarders, I'm talking like all sorts of craziness right now, the number of snowboarders reaches 10 million. Therefore, 1998 plus 15.72 is equivalent to 2013.72. What this tells us is that sometime during 2013, okay, maybe towards the end, the latter end of the year, going into 2014, but definitely still in 2013, the number of snowboarders reached 10 million, okay? All right, so thanks for tuning in. Good luck studying. And as you can see, intellectual comprehension of this material is not difficult at all. So order the complete Cram session so that you'll be able to answer a battery of questions about any Algebra 2 topic. All right.